Sorry for the slight delay there, but I'm here with another video, and today I'm going to be covering Pascal's principle, which is a topic in AP Physics 2, specifically in fluids. And without further ado, let's get right into it. So, here I drew a little diagram here, and let me just put the finishing touches. And so this is basically a container of fluid. All the blue stuff you see is supposed to be water. And we have two pistons here, a red piston on the left-hand side and a green one on the right-hand side. And they have different areas. So the red one has an area of A1, and we have the green one has an area of A2, and they're both different. And a person, he pushes down on F1 with a force of F1. Yeah, he pushes down with the force of F1. He pushes down on piston, we'll call this piston 1, piston 2, to make things a bit simpler. And it goes down a distance D. And we're going to assume that this is just filled with fresh water. Nothing special there. So, and it pushes down by D2, the D1, sorry, D1. I forgot to label this wrong. So it goes down a distance D1, and the piston has an area of A1, and so it displaces a volume. So it'll displace a certain amount of fluid from the left-hand side. And since water, like any other fluid, is an incompressible state of matter, you can't compress water. So the water will push this piston, the green piston, up, and it'll go up with the force of F2. And so since it's incompressible, a certain volume of fluid was taken from here. So you have whatever water was here. This amount of water is going to be moved. Well, it's going to move the water as a whole in this direction all the way to the green piston, and it'll push the green piston up. So with that, we can say, and it's going to be the same volume, and that's something you should recognize. And V1, it's going to push away a volume of V1, and it's going to push up here a volume of V2. And V1 and V2 are going to be equal. This is something you should recognize when doing a problem like this. So V1 is equal to V2. That means that the volume of water that you push down is going to be equal to the volume of water that gets pushed up on the other end of this pipe, or this tube. So based on that, let's try to get some equations for what V1 and V2 is, because just knowing that, we're trying to drive Pascal's principle, which is not that the volumes are equal. But we can take something called the conservation of energy, which is something you might remember from Physics 1. And what it basically is F work, which is represented by W, is equal to F times D, force times distance. And you might notice that we have force, we have distance. And so what this is basically saying is that work 1, the amount of work you do on the piston, is the same work done out. Work in equals work out. That's basically what the conservation of energy is. Energy in equals energy out, assuming it's a closed system. And for this problem, we're going to assume that we are dealing with a closed system. So we have work 1 for piston 1, and that's going to be equal, according to the conservation of energy, equals work 2. And so that means that F1, which is the force that we put on the first piston, times the distance that piston moves, which is going to be D1, is equal to force 2 times D2, distance 2. Now this isn't Pascal's principle, and we're going to see what it is in just a bit. And so what this is here, and we have this so far, and so what I'm going to do next is I'm going to find out what the volume of water displaced is in terms of A and D. And this is actually simpler than you might think. You might be overthinking it a little, but it's actually just V1 is equal to A1 times D1. Now let's say we wanted to solve for D in this equation. Let's say we solve for D. So D1 is equal to V1 over A1. So now that we have that, we can confirm this, and we can swap this D1 right here and put it in right here. So we can bring this D1, well, we solved for D1, and then just bring it over right here. We can do the same thing for D2. Basically just switch all the subscripts to 2. D2 is equal to V2 over A2, and we can substitute it right here. And then from here, we can get Pascal's principle pretty simply. We're going to have F1 times V1 over A1, which is equal to all over A2 F2 is equal to F2 times V2 is equal to over A2. So these two sides are going to be equal, but that doesn't necessarily mean that F1 is equal to F2. It does not mean that A1 is equal to A2, but we found out here that V1 is going to be equal to V2. So one thing that we can do, we can actually just cancel these values since they're always going to be equal. And here is Pascal's principle. F1 over A1 is equal to F2 over A2. And so with this, you guys, some of you might recognize the equation of what this really means is that P is equal to F over A. And this is outside of this for now, but the pressure P is equal to F over A. And with this, we see that we're just left with F1 A1, F2 A2. And keep in mind, F1 represents the pressure we put on the red piston, so we put this on, or the person here put this on, and F2 A2 is the pressure put on by the water onto the green piston. So we can say that the pressure 1, is equal to pressure 2. So the pressure that you put on a object is equal to the pressure that goes out of the object, and that is Pascal's principle. Hopefully this was helpful.